Hey everyone, welcome Azure Cosmos DB Live TV. Welcome everyone. My name's Mark Brown. Episode 42. We're going to talk about Async IO for our Python SDK, and I have with me two guests for us this week. Gahl, Levy, how are you, sir? Good to see you again.
I'm doing great. Good to see you too, Mark.
Yeah, Simon, how are you?
I'm doing good, Mark. Thank you for
Good.
asking.
Your first time on the show. Gahl here, of course, is a well-trodden warrior on our broadcast here. So welcome, Simon, to the show. Hopefully this is a nice experience for you, and that you will join us in future episodes for anything Python, right? So you just joined the team, right? So or not too long ago, I guess, right?
Yeah.
And you're working on just our Python SDK, or is there other stuff you're working on too?
Mostly working on the Python SDK. I've also, helped a little bit with the JavaScript SDK, and I am looking forward to doing some work on the Java one as well. But with that said, yes, I am just mostly working in Python.
Okay. Well, that's great. So I know this is a feature we've been waiting on for some time, or at least I know customers have said, hey, we would love if we had Async IO with your Python SDK. So why don't I get into this? And Gahl, you kind of walk us through, I guess, kind of what's new and different about our new SDK for Python here.
Yeah. So as you know, we have many Python developers using Azure Cosmos DB's SQL API, and we have a Python SDK specifically for the SQL API. And with this Async IO support, we're making it much easier for developers to develop concurrent code. And in terms of support, Async IO right now is in preview, and it's available for anyone to download and use with the SQL API. So for folks who aren't really aware of what Async IO is, it's a library that makes concurrent performance very, very easy to use. And we have docs that lead you directly to like step-by-step of how to use it. But it essentially just makes writing performance concurrent code easier to do than otherwise. And if you're a user, you'd want to use Async IO in several cases. The main one is where you have many IO operations. So for example, you're making many calls to Azure Cosmos DB with queries that take some amount of time to run. And if you're making many queries, instead of running them, one, wait for the result, another, wait for the result, you want to run them all pretty much at the same time, as close as you can, and wait for all the results to return, because parallelizing these queries makes your application run faster. And that's what we mean here when we say, running multiple IO operations at the same time. And instead of having to wait for one thing to return, you can wait for many queries to return at the same time. And that additional time that you have, you can use to do other things in your application instead of just waiting for the database to return queries.
Can I ask a question?
Yeah, definitely.
I don't know if you talk about this later, and we may have talked about this in the past, but Python is still single-threaded, right?
Mm-hmm.
Yes.
So I can't go. So even with this async IO support, I can't go and create like an array of threads or tasks or whatever is similar, and then go and just dispatch IO operations on each of them, and then just do an await or when all on them, right? So that's.
Yeah, so this works a bit differently. Like in Python, you can use multi-process and stuff and run multiple processes and different cores. This is doing none of that. This is specifically targeted for cases where you have a lot of IO-bound operations and you don't want to wait for them, synchronously to return one after the other. And in your application, you can build it in such a way with the Async IO library where you don't have to wait. You can dispatch a bunch of them at once and then wait for them to return, and meanwhile do something else in your code. I actually have a diagram in the next slide where I can kind of speak to that.
Sure.
Yeah, let me just go to that. Yeah, so this kind of just shows how it works. So with synchronous code, you're running a query. Imagine overtime is that arrow. You have like a graph over time. This is what's occurring. So first you're running a query, and then that query goes to Azure Cosmos DB. It's processing that query, and then you get the result. And then you have another query. Send that query, you wait for it to process, and then you get a result. This is assuming you have, like, for example, 2 queries to run, or 5 queries to run, or 100,000 queries to run. But this is synchronous code essentially. With Async IO, since you already know my application has to run these 2 queries in this very simple example, what you do is you basically use Async IO to run these 2 queries, one after the other. But instead of waiting for the result in your code, you wait for all the results to return from Async IO. In the meantime, you can do something else while it's processing. But instead of having to wait for each query's result and then launch the next one, you can just do it all at the same time. And Azure Cosmos DB is an extremely scalable database, so it can process all these queries at once, and it won't really slow down by having to do so. So you're really saving time by doing it this way.
Yep. Okay. Makes sense.
Yeah. And this is a very simple base case. There's tons of ways you can expand on this, but the basic things as a user you need to know is Async IO support right now is available in preview, which means beta, in the Python SDK, and we have a link here that you can download it from directly. And any version 4.3 and the latest is what you want to download. It's important to note that to take advantage of Async IO, you need to use the new Cosmos client, which is azure.cosmos.aio, which is the async client. It's not the synchronous client. There's an async client that's new. And obviously, you have to use the async and await keywords to perform these async operations, or nothing will, the async part will not actually happen.
If you don't await it, it never comes back.
Yeah.
Right. So
Yes.
just dispatch and whoop, gone. Okay. Very cool. All right. Well, you want to kind of show us what this looks like, I guess, then?
Yeah, I'll hand it off to Simon, who's
Sure.
working directly on this.
Let's switch it over to some code here. And Simon, show us what you
Absolutely.
got.
So first off, I guess I want to circle back and talk about a couple of things that Gahl touched on. One of the things is the package where you will find this asynchronous client. As you can see, you would normally just use the Cosmos client from Azure Cosmos. This, like Gahl mentioned, is in parity with our synchronous client, but this is the new one that we're doing all this work on, and that has these asynchronous capabilities to make your code be a little bit faster than what it might normally be. With this demo, what I really want to do is point out, I guess, certain differences that as a developer or as a user of our SDK, you might encounter when trying to use this new asynchronous client. For one thing, like Gahl also mentioned, it's the use of the async and await keywords. This is just something that most asynchronous code in different languages, not just in Python, have to some degree. It might not exactly look like this, but it is necessary in order to tell Python that you're running asynchronous code, as well as utilizing the Async IO package to run whatever code it is you want to run. Because this is, I guess, what glues together all of the asynchronous code that you write and what makes it run in an asynchronous manner. First thing I want to talk about in terms of the changes that have happened are the new Cosmos client needing a context manager. With your normal synchronous client, when you initialize it, there are certain I/O operations that need to happen in order for the client to be properly used, like getting your database account information. Maybe it needs to get some partition key information from your container. Whatever this is, this warm-up needs to do this network calls. With asynchronous code, the way that this looks is through utilizing a context manager that is built into the client. How can we use this context manager? By initializing the client using the async with keywords, and then setting it to some variable, which we'll use as your client. There are many advantages to doing this. For one thing, it's the warm-up all being taken care of for you. You don't have to worry about the client not working in a particular manner or having some funky functionality because you initialized it wrong. This way, that all of that will be taken care of by the context manager. And then second hand is not only the warm-up, but it's also the closing of the client. Because this is asynchronous, you would have to manually close the client once you are done using it. But with this context manager, you don't have the need to do that. Once your code goes out of the scope of this context, the client will close on its own, and you can make sure that that connection is going to be closed, and you don't have to worry about that anymore.
So this is basically like a using block in C#, this async with.
Yes, I would assume so. Yes.
So would this maintain the live instance of the client between calls, or does it's gone once it goes out of scope in this function?
Once it goes out of scope, you would need to reinitialize the client.
I see.
I had this little code down here to say like this would be out on the client context. This do something. Once we leave this, I guess, stack of code lined up here, the client is no longer there. It is closed, and well, I mean, I guess you're basically done with it unless you want to reinitialize it and do this all over again.
So if I wanted to keep this thing alive, I'd need to keep basically a reference to it, and it's at some parent level resource, whether it's in
That's a good understanding.
Usually, you just have all the code that you need under that context, or if you need something you need to pass around, you would create it in a different way, right?
Yeah, I mean, you could pass it around within this context as well, like I said. But otherwise, there's no real way for your code to even reference the client that you created, right?
Yeah.
Got it.
Then again, going back to like the little keywords that come with utilizing asynchronous code in Python. As you can see, most operations that do some sort of network call have the await keyword on them. That's because they're doing network calls. So it is expected that you're going to need this keyword in order to obtain the actual result and not some response that hasn't been computed yet, or that hasn't been properly executed by the server. As you can see, we have all sorts of operations here, creating the database, creating the container. I also have this little showcase here to show that to create several items, for instance, that does not change the way that you would write the for loop, for instance. You also reading items, reading containers, reading database, all that information will also be methods that need to be awaited, as well as anything that has to do with deleting an item or a container or a database. With that said, yes, please.
It might also be worth calling out that the await keyword is very it's async IO specific, and you can't just add it to any function. A function has to be awaitable, as in it knows how to hand back the process basically back to the program in a way where the IO operation can continue. Otherwise, it won't work correctly. So the function has to be awaitable in order to use the await keyword. You can't just throw it around wherever you want.
Okay.
Yeah, how you can just be putting that on everything.
Okay.
But then there is some operations that do not need the await keyword. For instance, the get database client or the get container client. That is because these methods, as some of our users might know, some might not, but they basically just create an object for you to interact with, and then that object will be the one that you use, to make all of these calls.
It doesn't even it creates a proxy, doesn't it?
Yes.
Right. And it actually doesn't do diddly until you actually reference it. Right. So,
you might be like trying to get some container client that doesn't exist, and you wouldn't know until you try to use it.
Yep.
But yeah, so because of that, clearly you don't have a need to make this an asynchronous method.
Yeah.
And then
good thing to know, folks. Hey, I just want to call this out. Just getting a reference to the container does not mean anything. You're still going to get latency on your first call. So if you're curious, hey, why is my first call? I have my container reference, but it's still so slow. You got to use it first. So
exactly.
Okay. Yeah. Sorry to interrupt. I just wanted to make that.
Those are good. Those are good things to point out. And then I guess one curious thing that one might be like, why doesn't that have an await keyword? Is query methods. Query items, read all items, query containers, query databases. All of these methods do not have an await keyword because the way they work under the hood is a little bit different in the way they make their network calls. And I'll get into that with this example, for instance. As you can see, we don't have like an await here or anything like that. we just get our result from these query items. And then in order to properly iterate over this, we do need to do an async for loop. So what this really looks like is just basically a for loop where you're just awaiting results as they come. So it would be something not too different from doing this. But the reason why we have to do this for queries specifically is because the response from these queries are async iterable objects. And because of this, these async iterable objects will only perform the network calls to retrieve your items once you await for them the way you would await a delete or a read or a create. One thing to point out that I think is pretty cool also is the fact that list comprehension does work with the asynchronous client and asynchronous code as well. So if you are generally, utilizing your query results and putting them in lists and then, doing something with those lists within the scope of your application, an easy way to get those results in like basically just a one-liner is by using list comprehension, which, like I mentioned before, supports the async for capabilities that you would need to get the results from the query. With that said, I guess I want to just ask real quick if there's any questions.
So, so there's not a syntax to see if there's more results in there. It just will go back until there is any, and then it just drops out of the loop. Is that how this works with the?
Yes. Yeah. The implementation of this just keeps retrieving the next object until we are out of objects. Yeah. Basically.
Got it. All right. So more concise than what we've got in our Java and C# SDKs.
Yeah. And I guess, I actually just realized, but one little thing to point out as well, our query items method in the synchronous client takes in normally an enable cross-partition query parameter if you would like to do that. With the asynchronous client, you can always pass that in. It's not going to make a difference. But we've also added functionality that makes it such that if you do not pass in a partition key, then by default, we do a cross-partition query. It just made sense, and so we have.
So I don't have to flag it as cross-partition.
No longer.
If I omit the partition key, you're going to set that to true anyway.
Yes.
I see. Oh,
that's I guess outside the scope of the Async IO, but it's just a little thing to bring up on like little improvements and changes that we've made to the async.
Yeah. Hey, anything Python SDK is inbound. It's all good. So
perfect.
Yeah.
Well, with that said, then I do want to bring up that we've also, with all these new changes that we've brought up, we've created a lot of asynchronous samples to kind of show users how to use this functionality, so you don't only have to watch this video. We've obviously also updated the README and made sure to add comments as much as we can. And this is a code snippet that I stole from one of our async samples that is called examples async. And I basically just wanted to quickly run it to show you guys that this works. It's doing exactly what it's supposed to be doing. And that you too can just basically load in your credentials and start running the samples and trying to fit them to your application in whatever way you see fit.
I get a question from a viewer. I think back on your other example there, speaking of list comprehension, what about generator works?
What about generator works?
Yeah, I don't know what that means.
If you can use it in a generator.
Yeah,
that's a good question. I'm not sure.
That is a good question.
Can you explain what you mean there? What generator?
Yeah. So it's like in a Python generator function, if you can use async there. I think the answer is yes. I'm not 100% sure. There should be some documentation around that, but I'm not sure.
Yeah, I would have to read about that as well. I'm sorry. But great question. More things for us to look into.
Yep.
Always good.
Okay.
But yeah, I guess to end the demo, if that's okay, I'm just gonna, basically run this. Like I mentioned, you can find this same exact code snippet already in our SDK. But yeah, let me.
Sure. While you're going here, Bilal here says yes, that's correct. So, so if it works for those types of things, then okay, good. Or you're going to check, or Bilal, you can check and then just
yes,
complain
you're
to
always welcome to check as well.
complain to us on Twitter at AzureCosmosDB.com, and we'll see it. Okay, got a demo here. You're running samples.
Yep. This is in the wrong folder. Now that ran very, very fast. But as you can see, we would have had some errors thrown, there are different cases that this scenario tries to take care of. But the fact that everything printed as it went through the code, and we can see all the different products that we generated. We see we were able to read the database properly, change the TTL, the time to live on the container, create a user by the name of Walter Harp, and then the sample finished running. This is one of many samples that we have released, like I mentioned before. And yeah, I think that's...
Are these all up in your new async docs here? Should I put that back out, or where can people find all the samples? Will they find them here in our Python async docs?
Oh, that's a good one. I mean, you will find them in the
or in your SDK package, maybe?
In the SDK package, yeah.
Okay, let me put that one up. So go download our new Python SDK.
Yes.
I've got the link up here for folks now, so you can. I'll leave that up so you can screen cap it or furiously jot it down with a pencil and paper.
I always love writing code down with pencil and paper. Reminds me.
Dude, I don't even recognize my own handwriting. Actually, I need to type it. So, and then if I try to use my phone, invariably I will fat finger, so I won't be able to even read that later either. It'll be some.
That's if autocorrect doesn't get in the way and just.
Oh, certainly autocorrect's going to be there all the time, turning my words from something into duck.
It still messes up my name from time to time.
It's never duck, by the way. Just
it never is.
To answer the user's question, I looked it up. I'm like 98% sure. It's fine. You just add that to the, within the generator code, and then you can iterate over it that way. I'm assuming we're going to be running, the user's trying to run multiple queries within each iteration of the generator. So I think it should work. I see plenty of Async IO examples with generators, so it should be able to fit in there in the same way.
And why don't you drop this into, so this is where the samples are specifically, right? Yeah. So this is in our GitHub repo. Sorry, not an AKA MS-Link, folks. Yeah. I'll leave that up a little bit longer so that you can jot that down with your pencil.
We have
a pen. Maybe you're using a pen. I don't know. Maybe it's a pencil. Maybe you got it from a round of mini golf. I don't know where I'm coming from. So, okay. Very cool. Is there other stuff you guys wanted to show me, or was that it for our show this week? Oh, wait, I got more stuff in private chat here. What's going on?
Oh, I was just sharing the link.
Yeah,
I got the
it seems like the document.
Oh, is it the async doc, the same one?
Works pretty good.
Yeah, it's the same one.
Oh, it is? Oh, well then here, I'll put this one back up. There you go. Okay, better, shorter, more concise.
Shorter.
So probably has other stuff on there too that's just as good or good for you. So, well, this is really cool, folks. I'm really excited. I know our Python users really love our Python SDK, and it's needed a little bit of love. And this is really great. I'll say this, I had my second show ever was Rodrigo talking about our Python SDK. And I don't know where it came from, but it's actually one of the most viewed episodes that we've ever had. So maybe Python friends, watch this show and this one even just as high up there on the number of views as our original Python SDK episode back almost a year ago. So,
yeah. And I guess one last thing to mention to users is, we value all of your feedback. This Async IO product is in preview right now, and we're always releasing fixes to it. So if you have any questions, find any issues, have any comments on things you want to see different, don't hesitate to drop feedback to us and GitHub, etc. And we're here for you.
So should they do that in our Python SDK? So
the docs link should work for them to raise any issues or questions that they have.
Let me save that one, and I'll go back. Unfortunately, it's going to be a long URL again because our Python SDK sits within the same tree as the Azure SDKs. So there you have it. It's github.com/Azure/Azure SDK for Python with dashes in between, and then tree/main/SDK/Cosmos, and then /Azure-Cosmos, because we've got 2 repos inside our Cosmos folder there. There's our data plane SDK that Simon here and Gahl work on, and then our Azure Management SDK, which not many people realize, but we have a Azure Management SDK for all of the major SDKs that our Azure SDK team produces. So I should do a show on that someday. I made a whole bunch of samples around at least the .NET ones, but
yeah, worst case, that link, memorizing is like memorizing a phone number. As a kid, when you memorized a friend's new phone number, same thing. // main / It'd be too bad.
Just take a screen cap.
Yes, ideally, yes.
Or just search.
Just do a screen cap. It's way faster. Just another comment from Bilal here, and then I think we're done. Love the product. Have been using it for Cosmos Async for Python for a while, and gotta say it's great. Plans to put in control. So async keeps within RU boundaries. Okay, so any plans, guys, for a throughput? Well, I don't know how you mean by RU boundaries. Like you've got retry within our Python SDK, right? Can you put?
Yeah.
Does Python I'm guessing Python has an equivalent of poly, so I can create retry policies, right?
Yeah, we have retry logic and policies built in for our SDK.
Great. So my response header is going to have my x-retry whatever x milliseconds, right? That I can use if I 429 and then.
Yeah, you can catch the 429 errors basically, and
okay. So Python SDK does the same thing the other SDKs do, which is going to try once and then retry 9 times, right? And then throw a 429, kick that back out to the client, and then you can of course trap that with a status code, and then use poly and then the header value to say, okay, back off and retry it again.
Yeah. I'm not sure if it's helpful. Also, with this applies to SQL API and also the other APIs as well. You can set up auto scale on your as a throughput way of doing throughput in your database or container, and that way your RUs will scale up and down instantaneously based on your throughput needs. So if you for some reason need more RUs for a certain period of time, it'll scale up immediately, and then it'll go back down. Just depending on your needs, and you only pay for what you're actually using.
That's right. So if customers want to use our auto scale throughput configuration there, they certainly can. But even still, you're making a network call, right? So you should always have a retry. There should always be something like a poly or some kind of retry mechanism on there, right? Because you're going over a network, you're going over a WAN, and WANs can be flaky. Let's just face it, right? So you want to catch anything that's kind of temporal or transient or whatever weird stuff that can be retried for the most part. So anyway, hey, lesson number 2 today, folks. Make sure you use retry logic in every call across the network in the cloud. So just saying, you'll be happier. So, okay. Anything else, gents, with this today? No? All right. Well, you know what? This is really exciting. I'm glad you guys came on. It's been too long since I've had anything Python related on the show here. So this is good to see.
Happy to bring it back.
Simon, I'm hoping I get to see more of you coming up with all the new Python stuff you're going to be working on. So
you see enough of me, Mark. So it's
open. Gahl, of course, that extends to you, my friend. Of course. So you both have an open invitation to join us anytime you want. when you got some new Python stuff and you want to share it with the community here, just come on back.
Yeah. Hope to be back soon.
Okay, great. Well, thank you guys for showing up, being with us today. Thank you, everyone, for joining us. Just a couple of announcements here. So I want to mention our Cosmos DB user group meeting every month. We're not doing one. We just had one recently. We're not going to have one again until I think beginning of April, and then we'll skip and then go into May and June. But feel free to check out our meetup page here at aka.ms Cosmos DB user group and join us on our meetup page. And you can RSVP for our upcoming meetups here. And by the way, you can win a sticker and a cool neoprene coaster just for coming and asking questions. So come check that out. I don't have any, or we don't have any upcoming episodes scheduled yet. We're kind of entering a weird period where we're getting close to the build season here, build conference. So things kind of get a little quiet as people are heads down focused on getting stuff shipped. But we will start scheduling up some more episodes here coming up as we can. We've got a few things coming out before build, so hopefully we can get some new episodes out for you then. Other big thing coming up is Azure Cosmos DB Conf, April 19th and 20th. Come check out all the great stuff that customers and community folks are building, running in 3 live streams, Americas, APAC, and EMEA, each for 3 hours of awesome, unique content. Lots of on-demand sessions too. Come check out what people are building and learn kind of the latest and greatest about Cosmos DB and how people are using it, and get tips and tricks and learn from people that have worked on building with it. So that's it. Certainly, if you want to catch any of our other 41 episodes on Azure Cosmos DB Live TV, come check us out there. You can watch all our old episodes on YouTube. Even our second episode where we had Rodrigo talking about Python SDK. You can watch it, and then you can binge watch that one and Gahl and Simon here and get your Python SDK fill for the day, hopefully. So anyway, I don't see any questions, and I think that's it for us this week. So again, Simon, Gahl, thank you so much for joining us, and welcome back. Come back anytime.
Thanks, Mark.
Thank you so much, Mark.
Okay. Thank you, everyone. We'll see you next time.